All right, today we're talking about absolute value equations. So first of all, quick refresher, what does an absolute value graph look like? Let's check it out. So a basic absolute value graph, right, of f of x equals the absolute value of x. Well, let's graph by point plotting. Based on what we know about absolute value, what does it do? It leaves something that's positive totally alone, right? It spits it right back out. But if something's negative, it just makes it positive, right? That's kind of the basic understanding of absolute value that folks usually have. What is the absolute value of 0? Let's start there. Well, absolute value of 0 is 0. Absolute value of 1, well, again, if something's positive, it just spits it right back out. So absolute value of 1 is 1. Same thing with 2. Absolute value of 2 is 2. 3 is 3. 4 is 4, etc. Right, so we have 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. All right, and then as we become negative, right, if we take the absolute value of -1, again, absolute value takes negative things and kind of makes them positive, right? So the absolute value of -1 would be +1. Absolute value of negative, right? -1, 1. Absolute value of -2 would be +2. -3, +3. -4, +4. Right? We put in -2, we get out 2. We put in -3, we put out 3. -4, 4. Okay, so when we connect these, we end up with this sort of V-shaped graph, right? Why is it like this? Well, essentially, we're kind of taking the graph of the line y equals x. We are familiar with that line from inverses, right? Because that was the line we flipped over, right? A line with a slope of 1 and a y-intercept of 0, right? Also is where the y value and the x value are the same. So, right, these points follow that line. But when we become negative, when we look at the negative x values, we have what it would be, but flipped, right? Because we've flipped the sign of the y, right? And it kind of looks like it's bouncing off the x-axis, like a mirror or something. Okay, so how do we graph absolute value equations? We just use our transformation rules. It's simple as that. So let's say we were asked to graph f of x equals 2 times the absolute value of x plus 3 plus 4. We'll do that here. Spoiler alert, it's going to be in kind of the top half of the graph, so I'm not going to draw the rest just to kind of save space. Okay, so let's look at this. What kind of transformations do we need to do? Well, we've got this 2, we've got plus 3, and we've got plus 4. Which one comes first? How do we figure out what comes first? Well, we do parentheses first, so we can look inside of the function, right? Our original function was absolute value of x. So now we have absolute value of x plus 3. So we have this plus 3, which means we're going to shift our x values, right? Because that plus 3 is kind of happening to the x. So we're shifting the x values. Stuff that's on the inside is going to be kind of the opposite of what we think it's going to be. This is number 1. We're going to shift left 3 first. All right, then after parentheses, we look at, there's no exponents, we have multiplication. Multiplication is here, this guy. What does multiplying by 2 on the outside, something greater than 1 on the outside, do? Well, this is going to be a vertical stretch, right? By 2. Right? Outside affects the y values, so that's vertical. And when it's outside, it's going to do exactly what we think it's going to do, so we're stretching by 2. Last guy, again, outside is y values, so adding 4 to every y value is just going to shift up by 4. Okay, so what are we starting with? Well, we're starting with this guy, right? So let's kind of draw our initial guy. So this is kind of step 0, right? We can put this as 0 or maybe original, or I don't know. Maybe it's O for original, who knows? Okay, so first we are shifting left. Looks like we've got 1, 2, 3 left. So our new kind of important point starts right there. And these lines, we kind of draw our V again. Ooh, that side was not straight. Whoops. Okay, so that's 1. That's our first transformation. Second transformation is to stretch vertically by 2. So each of these values need to be twice as tall as they were before. So if this guy was here, then my new guy should be here, right? If this guy was here, then my new guy should be about here, right? So, and then similarly, if we're about 1 over on this side, we should be around here, and maybe like here. So this is our new guy that's been shifted up. And then we shift the whole thing up by 4. So 1, 2, 3, 4. So now our graph starts about here. And this is our final one, so I'm just going to draw it straight like so. That was 2, and this is our third and final guy. So this is f of x. So we just have to follow our regular transformation rules for absolute value. It's just the same. We've gotten tons of practice with transformations. Let's talk about how to solve an absolute value equation. In order to do that, we need to talk about what an absolute value actually truly is. What is the actual definition? Well, the absolute value of any real number is its distance from 0 on the number line. What does that mean? Well, real quick, let's look at our trusty number line. So we're looking for a distance from 0, and let's say we wanted to graph the absolute value of x equals some number k. Well, then that means I'm looking for every number that is k, right? This is its distance. This is x's distance from 0. What is k away from 0? Well, this number is k, right? K plus 0 is k. But there's a second number that's also k away from 0, right? If we go k in this direction, what's this number? Negative k, right? What is this saying? This is saying the distance between 0 and x is k. That's all this is saying. The distance between 0 and x is k. And so this is one way of saying it. This is a second way of saying it. And a third way of saying it. So then x is equal to both of these, right? So x is k and x is negative k. So when we're solving for an absolute value, when we're looking for something inside of an absolute value, we can remove the absolute value bars, and when we do that, we have to set whatever's inside equal to both positive and negative k. So, how can we solve an absolute value equation? Well, here are the steps. Number 1, and this is very important, we need to isolate the absolute value. If we don't do this, then the rest of our steps don't work. If there's anything else we can't just remove the absolute value bars by themselves. We have to make sure that it's isolated first. This is something that lots of folks forget, so please make sure that you make a note of this and remember to do it for every problem. So we isolate the absolute value, then we want to split. What do I mean by split? Well, we split into 2. We have our first equation, equation 1. This is the equation as is, with absolute value bars removed. And then we have equation 2, which is the equation with absolute value bars removed. And the sign flipped on the other side of the equal sign. We'll see what this means in just a second. We'll look at this. And then 3, we want to solve for both. Solve both equations. Okay. Example. So let's say we've got 4 plus 2 absolute value x plus 3 equals 10. Well, we're trying to get to this x. We're trying to solve for x, so we're trying to get x on its own. So that means we definitely have to get it outside of these absolute value bars, which means we need to remove the absolute value bars. In order to do that, again, we have to isolate first. So we've got to get rid of this stuff that's on the outside. So we want to subtract the 4 over, right? We can't add these guys because this 2 is multiplied by this stuff. We cannot add these. We have to subtract 4 from both sides. So we start with 2 equals 6. Okay, now we're almost alone. The absolute value is almost alone. We have to get rid of this 2, so we should divide. So we divide both sides by 2, and we end up with x plus 3 equals 3. Now our absolute value is isolated, so we can go ahead and split. When I split this guy into 2, I get my first equation, which is the equation as is with the absolute value bars removed. So I get to just take the absolute value bars out. And then on the other side, we write the equation with the absolute value bars removed, but we need to flip the sign of whatever is on the other side of the equal sign. So -3 here, right? And again, thinking about what we talked about with our definition, this is the stuff that was on the inside equal to positive and negative k, right? So now we solve. X plus 3 equals 3 means that x, we subtract 3 from both sides, we end up with 0. X plus 3 equals -3, we subtract 3 from both sides, we get x equals -6. Let's check these really quick. We can check when we solve something by just plugging it back in and making sure it works. Well, we have 0 plus 3 in here. We're looking at the absolute value of 3, which is just 3. So we have 4 plus 2 times 3, which is 4 plus 6, which is 10. So that checks out, right? We wanted it to equal 10. We can check -6 as well. We have 4 plus 2, absolute value of -6 plus 3. This equals 4 plus 2 times absolute value of -3. The absolute value of -3 is just 3. So we have 4 plus 2 times 3, which again gives us 4 plus 6, which is 10. So this checks out. So both of these are solutions. Okay, let's look at another one. This is number 2 in the lab manual. First of all, is it okay that we have b on the inside instead of x? Totally fine, right? A variable is just a variable. It could be anything. We could say, what's the absolute value of smiley face plus 4? And that would be fine, right? Variables can be anything. Okay, so we need to carry on business as usual. Our first thing we want to do is isolate, for sure. So we've got to get rid of this -3. We can do that by dividing both sides by -3. So we end up with b plus 4 equals 3. We've isolated, so now we can split. We have the equation as is, right? So equals +3, and then removed equal to -3. We solve over here, we subtract 4 from both sides, we get -1. We solve over here, we subtract 4, and we get -7. We can check if we want. -3 times, we want b to be -1, plus 4 is -3 times Well, absolute value of 3. So we end up with negative 3 times 3, which is negative 9. So that checks out. Second one is negative 3 times negative 7 plus 4. We end up with negative 3 times the absolute value of negative 3. Absolute value of negative 3 is positive 3, so we end up with negative 9. You might be asking, why are we checking all of these? Do we need to do that every time? Is it not going to work sometimes? Let's see. Example. All right, let's say we've got absolute value of x minus 2 plus 5 equals 3. All right, we want to isolate, of course, so we subtract 5 from both sides. All right, we're isolated, so let's go ahead and split. So we've got our equation as is over here without the absolute value bars, and then we remove them and we flip the sign on this guy. We solve for both here. We end up with x equals, we add 2 to both sides, so we get x equals 0. We add 2 over here, so we end up with x equals 4. Let's check these guys. So on top we have, which is absolute value of negative 2 plus 5, which gives me 2 plus 5, which is 7. So we wanted 3, right? So this does not work. So this is not a solution. Let's check the other one and see if that one works. So we have 4 minus 2 plus 5. We end up with the absolute value of 2 plus 5. We get positive 2 plus 5, which gives me 7. Again, we wanted 3, but we got 7, so this doesn't work either. So what is going on here? Well, let's take a quick look at this right here. What does absolute value do? It takes something that's negative and makes it positive. Otherwise, it just keeps it positive, right? So is an absolute value ever going to give us negative 2? It's not, right? It's always going to give us a positive number, so it's never going to give us negative 2. So there's no x value that I could plug in, right, that's going to make this equal to negative 2. So the answer here is no solution. This is something we need to watch out for. Absolute values cannot equal a negative number. So we can either keep this note in mind. So how can we avoid this in the future? How can we avoid going through all this work? Well, we just need to keep this in mind, right? We need to remember when we've isolated the absolute value that we need to look for a negative number here. And when that happens, we know that it's no solution, right? Because this can't be a negative. It might not show up at first, right? At first, we weren't equal to a negative. If we haven't isolated the absolute value, this number isn't going to really tell us much, right? We have to wait until we've isolated. Once we've isolated, if it's equal to a negative, it's no solution. If we don't want to look out for this, that's fine, but you will need to check every time, right? Because sometimes you'll get answers that are wrong. So if you don't want to check every time, then you do need to keep this in mind. All right, let's do one more. Okay, let's say we have 3 absolute value 1/2 x minus 5 minus 4 equals -4. Okay, looking at this. First of all, is this a problem? Well, again, we don't know, right? We want to check to see if this number on the other side of the equal sign is negative once we've isolated. It doesn't matter before then, it can be whatever. We need to isolate first before we check. So let's go ahead and add 4 to both sides. We've got 3 equals 1/2 x minus 5 equals 0. We've got to get rid of this 3, so we divide by 3 on both sides. 0 divided by 3 is just 0. Now that we've isolated, we can check. Can an absolute value be equal to 0? Totally, right? So this is fine. So even though we started off negative, we only need to check what's going on here once we've isolated. Okay, let's split. So we've got 1/2 x minus 5 equals 0, and we've got 1/2 x minus 5 equals -0, but -0 is just 0. So these are actually the same equation. So we only have to solve this guy. We've got 1/2 x equals 5. We divide by 1/2 or multiply by 2, same thing. We end up with x equals 10. Again, as long as we're checking to make sure that once we've isolated we don't equal a negative number, we don't need to check our solution. We don't need to plug this back in. But if we skipped checking this number, then we do need to check the solution once we've found it, just to make sure. All right, last one. This is number 3 from the lab manual. We need to isolate here. Again, doesn't matter that we don't have an x and we have an a, that's fine. We need to isolate this guy, so we subtract 7 from both sides. Now we are isolated. We check to make sure this isn't negative. It's clearly positive, so we can go ahead and split. We've got 2a minus 1 equals 5, and 2a minus 1 equals -5. Then we solve for a in both places. We add 1 to both sides over here. We divide by 2, we get a equals 3. We add 1, we get 2a equals -4. We divide by 2, and we get -2. These are my solutions. Again, we don't have to plug back in because we checked up here that this was not negative. Okay, that's all I have for y'all today.